Why don't clouds fall? What are they even made of? Water vapor or liquid water? As it turns out, they are made of liquid water, so that begs the question, why don't they fall? Since gravity is still working, why don't they fall? To help answer this question, we can look at the forces involved, which are gravity, drag, and buoyancy. We all know what gravity is. Although I can't explain why or how it works, I can explain what it does and can calculate for it. All masses pull towards each other due to gravity, based on Newton's law of universal gravitation, that says that the force of gravity is equal to the universal gravitational constant g, multiplied by the mass of whatever two objects we are looking for, divided by the radius between them, squared. Drag is an easier concept, but a lot harder to calculate for, and so we will calculate it last. Drag is a force that comes from moving many tiny fluid particles, like that in water or air, that can only oppose the forward progress, unless there is wind or a wind equivalent in the fluid. There are videos in the description below that are great resources related to air resistance and drag that you can watch if you are interested, but the basic idea is that an object moves and hits many different air particles, which creates an elastic collision, which is a collision where two objects bounce off of each other. And what you see now on screen is what a stream may look like when simplified into semi-large balls. I feel like it's a good demonstration of how drag works in general. You can also look at it with the arrow method, which I do not fully understand, and so that's why I have the links in the description below if you want to go deeper. Buoyancy is the upwards force due to a difference in pressure between two areas of the water or fluid. In the air, it generally has a very small effect, especially at the level of clouds. But I'm still going to put it into effect because I want to get as close of an answer as I can possibly get. Think about it this way. Imagine you are swimming in a pool. The deeper down you go, the more pressure you feel on your body. And on a small scale, that pressure difference causes a force in any fluid. That is why helium balloons float, because they are big enough and light enough that that difference in pressure can overpower the gravitational force. Real quickly, I have COVID, so the rest of the audio, including that last part, will sound like I'm sick because I am. So, sorry about that, and also please subscribe to my channel. It really helps me out, and it would be really special, and you can have a huge impact in the community if you comment down below. So, thank you so much, and back onto the video. Now, just a rudimentary reminder about the water cycle. The water cycle begins as liquid runoff and then evaporates into water vapor. When the vapor gets high up, it can turn into water in the form of clouds, and then will come back down when oversaturated. All that just to remind and show that the clouds are made of just water droplets. Quick disclaimer for the next little bit, there will be a lot of calculations, so go to the timestamp on screen if you don't like that. All of our definitions are written on the top left, and all in standard units, kilograms, meters, seconds, etc. That p-looking thing is called rho. It is a Greek letter typically used for density. The equation for buoyancy, negative rho times g times v, is written and added to the force of gravity, set equal to F sub w, meaning without. This is because they are the only two forces that could possibly keep the clouds steady in the sky. The force of gravity is just mass times the local acceleration due to gravity, known as little g. We can simplify the variables such that the forces match and can be combined to get us g times v, rho minus rho. Then a few variables are substituted, and then we are done. The takeaway from those calculations initially is that clouds do fall. Our calculations ended up with a non-zero number, leaving the only force to be drag. Drag can only oppose a force, not shift it in the other direction, meaning that clouds do fall. They just fall slowly. Let me explain. This is a graph that I made that shows the terminal velocities at different radii, which I will get into the technical details in a few seconds. Basically, the overview is that small water particles don't move very quickly and can easily be moved around by just a little bit of wind. Now, I will show you how to get to that point. This brings us to terminal velocity. There is very quickly a speed of an object in which it can no longer speed up. This occurs because of the equation for drag, 1/2 a times the coefficient of drag multiplied by rho, multiplied by velocity squared. Now this is important because that velocity squared means that eventually the velocity will increase such that the forces cancel each other out. So the force without drag minus the force of drag equals 0. And that is what we're looking for. That is the terminal velocity. The coefficient of drag is a constant, and this can only be found out experimentally or from calculations that I'm not exactly sure how to use. I do know, however, that for a sphere, the coefficient of drag is 0.5 exactly. Then, as mentioned before, rho is the density, so the density of the air in our case. That A stands for the cross-sectional area, and in the equation, I set it to pi r squared, and that is because the cross-section of a sphere will look exactly like a circle. The video dropped off, so I'm just going to show a picture of the final calculations. Pause the video if you want to see how I arrived at my final answer. The graph on screen shows how a particle in a cloud will only fall at around 1 meters per second, or about 2 miles per hour, assuming no wind. And because of this, it makes sense that we don't see any falling, because some clouds would take over 2 hours to fall without any wind. And in addition to this, wind does exist and can easily keep them up for longer. And that's about it for today. Thank you so much for watching, and remember that you matter and are valuable to someone in your life. Thanks so much for watching, and have a nice day. Goodbye.